Hi there and welcome again to the channel here. Today's video is a follow-up to a video I did recently on the remainder and the factor theorem, because today we want to do an actual examination problem. So I brought you question number 5 from paper 3 of 2022, which is from Maths 3, and the question reads as follows. P of x is equal to ax cubed minus 10x squared plus bx plus 8. Question A says, if x minus 2 is a factor of p of x and p prime of x, find a and b. In other words, if x minus 2 goes into p of x without leaving a remainder, and again into p prime of x without leaving a remainder, what is a and b? Question B says, with these values of a and b, factorize p of x. Now, we did some work on the remainder theorem recently, and we discovered that if we have a function f of x, and this is divided by x minus a, okay, so we divide f of x by x minus a, then we can write, this should give us something in the form of x minus a multiplied by some function q of x plus some remainder r. We know that from arithmetic. You divide 17 by 4, then the answer will be 4 plus 1. 1 is the remainder because, of course, 4 doesn't go into 17. But anyway, that's what we have here. F of x is divided by x minus a. Then we can write x minus a plus this quotient here, q of x, plus the remainder r. Now, if x minus a is a factor of f of x, then we know that there is no remainder. In other words, the r is equal to 0. So f of x will be written exactly as x minus a multiplied by the quotient q of x. What happens if we substitute a for x? Then we get f of a is equal to a minus a multiplied by q of x, which is equal to 0, because a minus a is equal to 0, so 0 times q of x is equal to 0. Therefore, we can conclude that if x minus a is a factor of f of x, then f of a is equal to 0. Let's just write this down here somewhere. So if, because we're going to use it in part a then, if x minus a is a factor of f of x, then straight away we know f of a is equal to 0, exactly. That then is the factor theorem. This is the remainder theorem. So here we want to make use of the factor theorem. Okay, let's go. Right? P of x, we are given is, here is our P of x. It's a polynomial, which is equal to a x cubed minus 10x squared plus b of x plus 8. Now, what do we know? We know that x minus 2 is a factor. So in this case, our a is equal to 2. So p of 2 should be equal to 0, our factor theorem. So we can write p of 2 is equal to, let's put now 2 for x. So this is 2 cubed, which is 8a here. 2 squared will be 4 times 10, which is 40. Here, that gives us 2b plus 8. Okay, so this is equal to 0 from that. let's simplify. We've got here minus 40 plus 8, which is minus 16. Hey, no, minus 32. So we have 8a plus 2b minus 32 is equal to 0. We can simplify this and say this will be our 4a plus b minus 16 is equal to 0, or 4a plus b is equal to 16. So let's write this down somewhere here. So 4a plus b is equal to 16. Right. That's equation number 1. We got it by making use of the fact that f of 2, p of 2 should be equal to 0. We substituted our 2 for x and we equated everything to 0. Simplifying, we arrived there. Okay, let's go to the next part, which says p prime of x. In other words, the second derivative of p of x is has a factor x minus 2. So there is our, sorry, I'm using it wrongly. There is our p of x up there again. So let's differentiate it with respect to x. So p prime of x is equal to 3a x squared minus 20x plus b. Now again, x minus 2 is a factor. So p prime of 2 is equal to 0. So p prime of 2 is equal to, let's first of all substitute 2 for that. So this is 4 times 3, which is 12a. Here it's 40, it's minus 40, plus b is equal to 0. Simplifying, we have 12a plus b is equal to 40. That is equation number 2. Right. So we want to solve these two simultaneous equations. From equation number 1, we know that b is equal to 16 minus 4a. So we can come over here and substitute for b and say this is 12a plus 16 minus 4a is equal to 40. Okay, so what happens here? 12 minus 4 is 8. Maybe I'm going too fast there, am I not? Okay, so 12 minus 4 is equal to 8a. Then we take our 16 to that side, it becomes 24. Okay, 40 minus 16 is 24. So therefore, dividing through by 8, we get a is equal to 3. Now a is equal to 3. What about b? b is equal to 16 minus 4 times 3, which is 12. So this is equal to 4. So we now have our two values for a and b. A is 3, b is 4. Okay, let's keep them in mind. Put them where I'll put them. Okay, so remember b is 4 there. So I can just write b is equal to 4, a is equal to 3. So I can clear all the stuff down here. I don't need this anymore. So, okay, because we want to proceed to part B then. Okay, so part B says, with these values of a and b, factorize p of x. Right. So now we know our a and b. We can write that our p of x is equal to, that's a 3 there, 3a cubed minus 10x squared plus 4x, because b is 4, plus 8, which of course is our cubic polynomial there. Now, we are supposed to factorize this. There's only one thing that we know. We know that x minus 2 is one of the factors. So, x minus 2 the highest power there is 1. X is raised to the power 1. Now here, the highest power of the polynomial is 3. So once we have one of the powers taken away, if you like, x to the power 1 is already gone. So the other factor of p of x, which is going to multiply x minus 2, has to be of degree 2. So we can write p of x as p of x is equal to x minus 2 multiplied by something that we don't know, but surely it must be of the highest degree should be 2. So it will be of the form ax squared plus bx plus c. This is so that when we multiply this x and this x here, we get our x cubed there. That's the highest power. It can't be x cubed because x times x cubed will give us 4. It can't just be x. X times x will give us an x squared. So we need something here of the second degree to combine with that to give us that. So we don't know a and b and c. These are just constants which we are going to find out. But whatever it is, it must be equal to that. So let's expand our brackets. So here we are, where this is equal to x times ax will be ax cubed. There you are, x cubed. Then x times bx will be plus bx squared. X times c will be plus cx. All right? Right. Then let's multiply the minus 2 there. Minus 2 times ax squared will be minus 2ax squared. Minus 2 times that will be minus 2bx. Minus 2 times c will be minus 2c. Right. Keep in mind, this is identical to that. It's an identity. These two are identities, exactly the same polynomial expressed differently. And here I've just expanded it. So if these are identical, it means that the corresponding powers of x have the same coefficient. So we can equate terms with the same powers of x. For example, here is our term with x cubed here. It has to be the same as that one there. So I can say, therefore, 3 is equal to a. Our a is equal to 3 because these two are identical. So straight away, I now know a is equal to 3. What else? I can see some constant. There's a constant term here, which is 8. Do we have a constant term here? Constant term here. There it is, minus 2c. So we can write minus 2c is equal to 8, which implies that c is equal to minus 4. So I've now got two of my constants in the bag. A is equal to 3, c is equal to minus 4. Right, we are left with b. But let's collect all the, let's write this in a way that collects all the terms with the same power. So I can write this as a x cubed plus x squared. Which terms have got x squared? We've got a b here and a minus 2a here. Right, let's collect our x's. We have got a c here and a minus 2b there. And of course, what is left is just my constant there. And that's why I was able to say this is equal to that and this is equal to that. Now I'm left with the terms with x squared and that one there. We have to still find our b. Right. Let's use this one. We now say c minus 2b, which is the term in x, should be equal to the coefficient of the term in x here, which is 4. So c minus 2b is equal to 4. But what is c? C we have found is 4. So we can say minus 4 minus 2b is equal to 4. Taking 4 to that side, we have minus 2b is equal to 8, which implies that b is equal to minus 4. So that minus 2 times minus 4 gives me a plus 8. Okay, but I need to check this because here I used this one to equate the terms in x. Let me use this one to equate the terms in x squared. Allow me to create a little space here. I'm running out of space. So here, the term in x squared here, the coefficient b minus 2a must also be equal to coefficient minus 10. So I can write b minus 2a is equal to minus 10, right? But a, I have found it to be 3. So I can say b minus 6 is equal to minus 10, meaning b is equal to minus 10 plus 6, I'm checking the 6, which is equal to minus 4. So it checks out. B is minus 4 there, B is minus 4 there. So my calculations are correct. Right, so now we have found our constants here. So allow me to write them here, to just book them here. So we said A is equal to 3, B is equal to minus 4, and C is equal to minus 4. Is that right? Is that what we got here? We got C is minus 4. Wait, yeah, C is minus 4. All right, okay. So now we are supposed to factorize this thing. So now we have got the coefficient. So we can write it there. Remember, we had written it in this form. So we just plug in the numbers. So this is equal to x minus 2. Bracket A, we said it's 3. So it's 3x squared. B is minus 4. It's minus 4x. C is minus 4. Minus 4. There we are. We have completely factorized that one there. Let me just summarize what we did in part B. What we did in part B, we first of all had to find our A and B from question A. And then we substituted, we ended up with a P of X is equal to that. Now, to factorize this, we were lucky enough to have been given one piece of information that x minus 2 is a factor of P of X. So we came here and we said, okay, this x minus 2 has to be multiplied by some function to give us our P of X. That function, since P of X is of degree 3, this function here must be of degree 2, because when you combine it with that, you have your x minus that to give you x3. So it should be a quadratic function, ax squared plus b of x, bx plus c. That's why we wrote it like that. Then you expand this expression, and then you start to equate the coefficients of the same powers of x. You equate the coefficient of the power of x cubed, x squared, and x, and the constants, and so forth, because this is an identity. For those of you who might have had a little problem with understanding this part here, I advise you to go back to the video where I did the factor and the remainder theorem, but it should be fairly simple. Till we meet you next time. Bye-bye.